So we have discussed what is random process and its spectral characteristics in the last class. Okay, so spectral characteristics are nothing but the frequency characteristics, yes or no? If you are obtaining the characteristics, so if you want to analyze the random process in the frequency domain, we use this spectral characteristics. Okay, so here we have discussed that the random process x of t is varying randomly, so you cannot apply Fourier transform directly. Okay, we cannot apply Fourier transform directly here. Okay, so that is why what we have to do, we will be taking the autocorrelation of this random process, and so that we are applying the Fourier transform. Okay, so if you are applying autocorrelation, Fourier transform to the autocorrelation, then it is called power spectral density function. Okay, so we have discussed that. What is power spectral density function? Power spectral density function will be denoted with Sxx of omega is the power spectral density function. So it is equal to what? It is equal to Fourier transform of Rxx of tau. So it is equal to e power minus omega tau d tau. Okay. Now how do you find out autocorrelation function? Rxx of tau. Autocorrelation function is nothing but the inverse Fourier transform of power spectral density function. So it is Rxx of tau is equal to 1 by 2 pi integral minus infinity to plus infinity Sxx of omega e power j omega tau d omega. Okay, so this is one of the formula for finding power spectral density function. Okay, so there is another formula to find out power spectral density function. The power spectral density function can also be obtained by the equation Sxx of omega is equal to limit t tends to infinity, the expected value of mod xt of omega square by 2t. This is the formula to obtain power spectral density function. Here, mod xt of omega square is xt of omega is nothing but the magnitude of Fourier transform, okay, of xt of tau. Magnitude of Fourier transform of xt of t. So what is xt of t here? Xt of t is nothing but we are taking only the interval minus t to plus t, so that we are getting xt of omega. So what is xt of omega is? It is the magnitude of Fourier transform of x of t over the interval minus t to plus t. Like this we can obtain Fourier transform. This we have discussed in the last class.